Hello, everybody. Welcome to class. Today we're going to be talking about where the electrons are located and how we are going to be able to determine where they're located. We need to know this kind of thing because electrons are really important to our everyday lives because they are part of the chemical reactions that happen all around us. So how electrons bond and how they react with other elements is going to be vitally important to us. So we have to know where the electrons are located on the energy levels and in the sublevels. And so we're going to be talking about those today. And so when we talk about this thing called electron configuration, we are literally speaking about the location of an element's electrons in terms of energy levels and sublevels. And it turns out that electrons follow some simple and easy to understand rules, but it definitely has a pattern. One of the rules that we have that has to be followed is that it is impossible to know both the location and the speed of an electron at the same time. This files back to if we change one, then we automatically change the other. Or if we examine one, then we automatically change the property of the other. And so that's what the Heisenberg uncertainty principle is also about. We also have, as you're going to see, two other rules that apply to how exactly are electrons filling these different energy levels. All right, so in an energy level, these are basically going to tell us, in general, the distance from the nucleus. If we have a low energy level, like a 1, it is very close to the nucleus. However, if we have a higher energy level, like a 7, those electrons on that energy level are very far from each other. So we know that we have energy levels of 1 through 7. And we know that because we have already made the connection that the period numbers help us know this by looking at a periodic table. Okay, so we also have something called sublevels, and sublevels are areas within the energy levels where electrons are found, and there are specific areas where electrons can be found. Let me go back. All right, so we want to make sure that we can go ahead and identify these and a little bit of facts about them as we're doing this. So the first is called the S sublevel. And you have heard this already because we have labeled our periodic table as the S block. The S sublevel can fit 2 electrons. Okay, then we have something called the P sublevel, and above in the pictures you see some general shapes of those, and the P sublevel can fit up to 6 electrons. Then we have the D sublevel, and in the D sublevel we can fit up to 10 electrons, and in the F sublevel we have exactly 14 electrons that fill the F sublevel. So we need to be able to remember that the sublevels each have a certain fixed amount of electrons that can fit there. It doesn't mean they're all going to be there based on how many electrons an element has, but they could fill those energy levels up if they were a big enough atom to be able to have that number of electrons. Okay, so let's move on to our next slide. Okay, so what is an electron configuration? An electron configuration is giving us a lot of information. An electron configuration is first telling us, the first number is telling us the energy level of the associated electrons that are being described here. It is also giving us the sublevel of what, in other words, which block are these electrons on the periodic table, but in the atom, we call them a sublevel. So this is the S sublevel, which corresponds to the blocks that we have drawn on the periodic table. And as you know already, because we drew those in, S, P, D, or F blocks are what we have. Then we also have the number of electrons which are currently located in this energy level, in the sublevel. And so you see a number here in a superscript position. And as you can see, once again, S can fit up to 2, P can fit up to 6, D can fit up to 10, and F can fit up to 14. Okay, so we have a large first number, a lowercase second letter representing the sublevel, and a superscript number that represents the number of electrons. All right, so when we are talking about, well, how does this look on the periodic table, we will need to go ahead and use some color coding. So if you will follow along with me, please. First, if you remember, we had our period numbers, which are also now called our energy levels. Okay, and then we had our blocks, and now we are going to start calling these our sublevels. And so we have the S block, the P block, the D block, and the F block. And so we can go ahead and label those appropriately for where they're located. Do you notice already that helium is not currently outlined in a color? And that is because helium is actually considered to be, its electrons are considered to be part of the S sublevel. So that means helium, while I know it is a noble gas, helium's electrons are found on the S sublevel. Okay, so when we are describing electrons of different elements on the periodic table, we are going to describe the entire location of all of the atom's electrons, starting from the ones very close to the beginning of where the nucleus is, very close to the nucleus, and then ones which are very far out. And I want to go back one. Very far to the outside. Now, as you can see, we have each row begins with, in other words, 1s, 2s, 3s, and 4s. As we move across the periodic table, we then come up with the p's. And then once we get to the fourth energy level, you might notice that we have the beginning is 4s1, but then we're going to run into the Ds. And the Ds are sort of special. The Ds actually are existing a little bit closer to the nucleus, so that you would expect these to all be one less energy level than the energy level that is listed as a period number to the left. So you will find that these are all beginning with 3D, 4D, 5D, and 6D. Now, once we get to the end of a row, then we are going to go back and describe the location of the electrons back on the fourth energy level, but in the P sublevel. Now, you might be wondering, how am I ever going to remember all of this? And we're going to practice using all of this, but I want to remind you that the S sublevel can fit 2 electrons. And if we think of each atom as having one more electron, then the 1s1 is actually describing the hydrogen electron. If we were to describe the helium electron, we would be describing the 1s2 electron. Okay, and so then that energy level is full. And once we have a full energy level, we are going to drop down to a higher energy level and describe where all the electrons are located on that energy level. And we're going to use our periodic table to move from left to right on the periodic table. Okay, so what if I had to describe carbon? If I had to describe carbon's full electron configuration, I know that carbon is number 6 on the periodic table. So I am going to start by saying, starting from the beginning, and I'm always going to start from the beginning, and the beginning is always at the 1s location. I'm going to start describing where all 6 of those electrons are. So on the first energy level, in the S sublevel, I have a total of 2 electrons that fit there. So I'm going to write down 1s2. Then I'm going to continue, because remember, we are talking about carbon here, and carbon has 6 electrons. So to show the rest of the electrons, I'm going to drop down to the second energy level, and I'm going to report those 2 electrons from the second energy level in the 2s2 position. Then I'm going to work across, because I have now filled up the S sublevel in the second energy level. I'm going to work across, and I come across the P sublevel. And in the P sublevel, I have a total of 2 electrons right here. So I'm going to report both of those electrons as being located on the second energy level in the P sublevel, and there are 2 electrons. Okay, so now I can report that, in fact, I have used 2, 4, 6 electrons, and that's exactly how many electrons that an atom of carbon has, 6 electrons. I can also report that on the outermost energy level, and the outermost energy level is always the largest energy level, that there are a total of 2 plus 2, or there are 4 valence electrons, which are electrons in the outermost energy level. Okay, so let's try another one and see if we can see how that works. Let's go ahead and try and see if we can do chlorine. All right, so let's take a look at chlorine's atom, and we're going to describe where all 17 electrons are for chlorine. So I'm always going to start at the beginning. I'm going to start at 1s, and I know that 2 electrons fit there. And then I'm going to drop down to the next energy level, and I'm going to use the 2s location, and I know that in the s, 2 electrons also fit there. Then I'm going to work across to the 2p sublevel, and I'm going to represent all 1, 2, 3, 4, 5, 6 electrons there. So I'm going to write this as 2p6. However, I have only to this point shown 10 electrons, and I need to show all 17. So I have filled up the second energy level, and now I'm going to drop down to the third energy level, and the first 2 electrons are going to be shown in the 3s location, so 3s2. Finally, I am going to move across to this 3p sublevel, and I'm going to represent the last 5 electrons, and I know there are 5 because here is chlorine, and I can count 1, 2, 3, 4, 5 electrons, which are in the 3p sublevel. So I'm going to represent this as chlorine ending in 3p5. Okay, if I had to report how many valence electrons chlorine has, I would look for the largest energy level, the outermost energy level, and I would add up the number of electrons that I have represented there. So chlorine has 7 valence electrons. Now, there is an easier way to do your valence electrons. Remember, you can simply look for the letter at the top of the periodic table that has the A next to it, and that tells you the number of valence electrons. So that matches. If we are going back to represent carbon, carbon had a 4A up above it, and that matches the 4 valence electrons there. Okay, so let's try another one and see if we can figure out what its electron configuration is. Let's go ahead and navigate to one that should be a little bit easier now that we've seen a little bit. Let's go ahead and say what the electron configuration of neon's atom would be. So neon, we know, has a total of 10 electrons, and we have to show all 10 electrons for neon, and we're going to begin where we always begin, at the 1s position. So we start by filling up the first 2 electrons in the 1s position, and we show 2 electrons there. And then we drop down to the next energy level, and we go to the 2, energy level 2, S sublevel, and we fill in those 2 electrons there. Okay, now I'm still moving across to the 2p, and I know I'm going to stop right here in neon's position, but I need to know how many electrons fit there. I know I'm in the p sublevel position, but now I'm going to count 1, 2, 3, 4, 5, 6. So I'm going to end this by saying neon's electron configuration is 1s2, 2s2, 2p6. All right. Now, when I am identifying the electrons for some larger atoms, like those in the fourth or fifth sublevel, then I need to pay attention to the fourth or fifth energy level, then I need to pay attention to the D sublevels. And please remember that what is going to happen here is that we're going to have a momentary reduction in energy level as we enter the D sublevel, but then we will come back to the regular energy level once we come out of the D sublevel and move into the P sublevel. So let's try one here. Let's go ahead and try, we'll try vanadium. And vanadium is located right here, number 23 on the periodic table. So that means we have 23 electrons we need to show. Okay, so in doing the vanadium, I am, as usual, going to start right here at the beginning. So for vanadium, I will have the first two electrons filling from the lowest energy level to the highest energy level. I will have the first two electrons in the 1s2 location. Then I'm going to drop down to the second energy level, and the next two electrons will be shown in the 2s2 sublevel. Working across to the right, the next 6 electrons are going to be shown in the 2p6 location. And then I'm going to drop down to the third energy level because I've filled the second energy level. Dropping to the third energy level, I will have 2 electrons in the S sublevel. Working across, I will have in the third energy level, the P sublevel, I will have 1, 2, 3, 4, 5, 6 electrons. And I've filled the third energy level. Now I'm going to work down to the fourth energy level. And at the fourth energy level, I will have 2 electrons, which fill the S sublevel. And then I get to the Ds. And I'm going to remember that I must use the 3D as the location in this sublevel. And I'm going to count 1, 2, 3 electrons. So I will end with 3D3. Okay, so the big thing that changes is that once you get to the D, this number is always lower than this number. So in this case, when we were talking about this one, remember we talked about the number of valence electrons being those electrons in the outermost energy level. And as you can see, the fourth energy level really is a larger, so outermost energy level. So vanadium would have only 2 valence electrons. Okay, whereas you might be tempted, well, the last one I wrote down was the D. The D is actually not on the outside. It's actually tucked inside between the 3S and P and the 4S. So it's actually tucked on the inside. So the outermost energy level in vanadium, and really any of the transition metals, is always the highest number, so the 4 or what have you. Okay, so before we go on, I realize that I have not also talked about the valence electrons for neon, and you might remember that neon was a noble gas, and over the noble gases there is an 8A, so we would expect the valence electrons to be 8 valence. So if I add up the electrons in the outermost energy level, those 2 electrons are 2 and 6, so in fact we do have 8 valence electrons. Okay, so let's continue with our presentation here and move ourselves along. Okay, so one thing to remember, and a good thing to remember, is that electrons enter their orbital locations from the lowest energy first. So the lowest energy first really is referring to, and I need to make sure, yep, okay. Really is referring to the electrons starting in the low energy and going to the highest energy. So using your periodic table in the order in which we have been reading it, the electrons that you wrote down last are the ones with the highest energy. So if you are asked which electrons have the highest energy for this particular element, you would say that that is the 3d6 electrons. Okay. Okay, when we get to start talking about D and F, and we already have started talking about D, but what about F? If you remember, F was written down here so it wouldn't mess up our periodic table, but the elements in the F sublevels really do fit right inside here, in between number 57 and 72, and then in between number 89 and number 104. They really fit right in there. And when we get to the F sublevel, we have specifically paying attention to that they fit right in there, but they also have another change in their energy levels. Now, the good thing that you need to know about the F sublevel is that at this level, you will not be asked about electron configurations in the F sublevel. I'm going to limit ourselves to everything up to and including the 5th energy level. Okay, so for D and F box, they are starting with a different sort of format. So let's pay attention to, you would expect them all to start with, and I'm going to make sure I can see this, 3D1, 4D1, 5D1, and 6D1. And then you would have, in these particular places, you'd have the F's come next. So we'd have 4F1, 4F2, 4F3, all the way to 4F14. And then you would come back to the D's and number 5D2, 5D3, and so forth. Okay, and so you do have to pay attention to that. That is why this is considered to be the upper level electron configurations and are not required by the scope of this class. Okay, we have reached the end of our presentation. I know you're going to have a lot of questions. I am glad to answer those when we are next in class together.